So hopefully you all have something that maybe looks kind of sort of like this in LARA already. You've already drawn the space, and maybe, yes, you already have a file that is very similar to this. Okay, maybe not exactly with this loudspeaker configuration, but something similar with a center cluster that you've come up with, and you've already on paper done now at least attempted to do the math for how you might think about delays on this, right? With putting front fills in. So what I want you to do now with your LARA is take your LARA file and add some front fills into it. Okay, because the one you have should only have center cluster, correct? So add some front fills into it on the steps, and you can think about how you do it. This is what I did. This is actually the one that I did for She Loves Me last year. That I gave to Gabriel, and so you can do something like this if you want, or pick, just figure something else out on your own as far as how you want to do front fills. It's going to have to be distributed in some way around because it's a thrust configuration, so you're going to need more than just one little row. So anyway, that's what I have here. I have 6 front fills. I have my center cluster, and then these 4 are really, I'm using those for reverb. They're not really part of my system, as you'll see if you look at how this lays out. Let me switch over to top view here, and let's find a group that is going to be meaningful. My dry group. Okay, I got pretty good coverage. That's at 1K. There's 2K. So yeah, so I'm fine. I'm not in a situation where I need to really be worrying a whole heck of a lot about fills. Right. This is the center cluster and my front fills. But the front fills are really only major players in these first few rows. Although I tipped them up pretty high. I mean, we were certainly hearing them all the way back here, but I wasn't getting the good stuff out of them. I was just using them as a stepping stone. Okay, so ultimately I decided not to hang any fills for this because I was able to get pretty decent coverage out of the center cluster itself, so I didn't really have any major holes I needed to plug. So how might we use this to figure out our precedence delays? Well, first thing you need to know is that there is a tool in LARA called listening locations, or listeners. And you can set those up in the same way you set up points when you're drawing it. So if I go back to my CAD here, I need to kind of figure out some listening locations. So let me put one here on this front row. So I'm going to drop a point 4 feet up there on the front row. And then I'll do another one. I'm going to do this one 5 feet up because my mix engineer will be standing right here. And they'll be standing. So I want to make sure I know what they're hearing. Okay, so I'll do that, and should I do one in the middle? What the heck? One in the middle. Okay. So let me find out where these are. All right, so looks like we're looking at 31.74 on the X and 1.667 on the Z. So if you go to your sound system menu here, where you would do installed loudspeakers, there's another thing called listeners. Okay, so I'm going to check that. I get this new window here. And I'm going to add a listener, so I hit add. And this will be my front row. And my X here is going to be 31.74. My Y is going to be 0, because I'm on center line, and my Z is 1.67. Okay? When I hit that little display button, then I can see it. So there's that little dot representing that person sitting in that front row. Okay? The other way to get them to show up is you go to this display menu, switches, and listeners. You turn that on, then it'll just automatically show all of them, just like it does with the point. So I can turn off the dots, for example. Switches, point labels, I can make those go away, but show the listeners. Okay, so let's add a couple more here. So here's my middle row listener hanging out. Full row. Here at 46.719, and Z is 8.08. Okay. Display, there he is. And then let's go find where my other one is. So this will be my back row. This guy is living 61.56, and the Z is 17.83. There we go. All right, so I have 3 listeners. Now look at this. I've made a group here that just has everything but my reverb fills, because I don't really care about those from a precedence point of view. Ultimately, I will add some delay to them, but it could be quite a bit because it's going to be reverb. But what I want to find out here is, what does the audience hear in what order? So there's this little button here, which has the little lines, vertical lines on it. This is your level delay display. And here you can pull up different locations. And the locations list are all the listeners you've installed in your system. So for example, I'm going to pull up front row and hit update. And it shows me this little graph of when things arrive. So let me zoom in a little bit. So this first one, if I click on that, it'll tell me what that is. So that is my front fill center left, which is going to be this one over here. This one is my front fill right left, which would be that one over there, that's hitting that center point. This one is my front fill right, which is going to be that one over there. But they're quite a bit quieter because they're so far off axis, so I'm not going to worry too much about those. But I can see that my front fill is coming first, and then this one back here is my center cluster, and I'm just calling loudspeaker 1. And I can see that my center cluster is arriving 14.8 milliseconds after my front fills, which is good. That's like already in precedence. And if you think about it, that makes sense because the center cluster is physically behind the front fills in this case. So there's a built-in precedence here. If I look at the middle row, I'll see similar effects. So here's, again, my front fill, center left, and probably the center right one is buried right underneath it too, because they're equidistant, so they would arrive at the same time. These are my other little front fills, and then this is going to be my loudspeaker, arriving 9.79 milliseconds after, which is also good. Yeah. Then my back row, front fill, center left, there it is, and then there's my loudspeaker 1. Now we're at 5.6 milliseconds. Okay, still technically okay. Then I have these front fills still arriving way off there, but they're quiet enough that they won't really worry about it. Remember that 10 dB rule, it works both ways. So something that is 10 dB quieter is not going to...
So if it's under the -10 line, you don't really need to worry about it.
Yeah, I'm not worrying too much about it at all. And if it's still, and technically this would still be within precedence anyway of that center cluster. So even if it were louder, I wouldn't worry too much about it either. It's not going to cause me any trouble in any variable or any metric. It's fine. Okay, so that's sort of interesting, yeah. You can kind of see how this works. However, I have not really considered how this works from the point of view of the actors. So if I add some actors onto this stage, what's this going to do? Ideally, I'd like them to arrive first, wouldn't I? So let's add some actors. If you go to JBL's website, you can download their this JBL full pro line, this ease SPK/DLL files. You can download that, and if you do, there's this cool little thing in there. So you go to there's different folders for the different product lines. The one called Components. There's a folder called Ease People, and they've actually made an ease file for like a human voice, and it's called Soundman J. And I don't know who this guy was, and
This was Soundman J.
I guess I'm not sure how they made this or how they measured him, but this is apparently JBL's opinion on the dispersion of a human voice. I don't know. I guess it's better than nothing. So I used to use just little front fill loudspeakers or something in place of actors. But now that I found this, I'm trying to use this. So anyway, let's import this guy, shall we, into our sound system. Let me go ahead and save this file first. So let's open our loudspeaker manager. And I'm going to, I got to convert it first, don't I? Let's convert it first. Polar view. Desktop. JBL Pro. You remember how to do this? Components. Ease People, soundmanj.lob. I'm curious. I want to see what this does. It's basically omnidirectional, it looks like. Certainly at 1K it is. What about at 4K? Yeah, so this is basically an omnidirectional loudspeaker.
Wait, can you do like 250 hertz?
Soundman J, where is he? So when we hang an omnidirectional cluster, we're actually just hanging.
You're hanging Soundman J.
He's in the follower rest.
Watch one of the kids in the freshman class.
We're going to call him Soundman J. He won't understand it for like an entire 2 years.
Like the version number? Like how many? Why did
No, but it was spelled J-A-Y. Like it
Well, let's make it look professional.
Play JBL, you know. What do we name a guy from our company? Oh, J.
So Soundman J is going to be, I'll just do the height of a head, so that we'll say 12 inches high, 8 inches wide, 8 inches deep, something like that maybe. Doesn't really matter.
Can't do a ovoid
No.
cabinet, an egg-shaped cabinet.
No.
Banging all over the cabinets.
So there you go. It's called Speaker, which is a little annoying. Let's see if we can rename this. I'm going to call this
Soundman J.
yeah, Soundman J.
He lives.
We'll see how it goes. Okay, so now I can put this in here. So let's figure out some locations for our Soundman J here. So that's about as far downstage as he'll go, I'm sure. So we'll do 5 feet up from there. So there he is, standing on the stage. That looks higher than 5 feet.
That does.
That looks better.
There we go.
Okay.
Oh, it's only 4.75.
All right, so let's install one here. So I'm going to add this. This will be downstage talker. And we'll use the Soundman J loudspeaker. X is 21.292. Z is 4.75. Okay. And there we go. There he is. All right, so now let's copy this and we'll shoot him upstage. Let's try just 15 feet for now. See how that goes. So we're going to make another one. This is upstage talker. And this will be 6.292 and 4.75. There he is. So now what I'm going to do is I'm going to create a new group. Group 8, and this is going to be my delay group. So I'm just going to include those center front fills because I know because I'm not measuring on that on the side seats. I don't need to worry about those side front fills for the purposes of delay. I'll just delay them the same way I delay everything else for the time being. So I'm going to add my center cluster and my 2 center front fills and my 2 talkers. And I'll call this my delay group. Okay, so now I can pull that up here and see the ones that are blue are my 2 talkers, my 2 front fills, and my center cluster. So that's what I'll see now. All right, so now if I pull up my little level delay display, pull up front row, here's what I get. There's my downstage talker. There's my front fill. I'm going to have to zoom a little bit here. So there's my downstage talker coming first. There's my front fill coming slightly thereafter. So why do you suppose that is? Isn't the talker standing physically behind that front fill? Just barely. It probably has to do with the depth, right? So however far down you have to go to the front fill is a little bit further down than you have to go up to get to the actor's voice. So it's a slightly shorter path. Not by much. I mean, we're only talking 1 millisecond difference, so it's barely a foot difference. But there you go. Okay, then my next one.
Does that still work?
No.
No.
So yeah, we got a problem here. So we got our downstage talker coming first, then our front fill coming, 1 millisecond. It'd be nice if that was bigger. But here's our problem. Our upstage talker comes 13.2 milliseconds, which would be 12 milliseconds after the front fill. So the front fill is coming first, which is not great. And then here's our center cluster shortly thereafter. So this is slightly out of whack now. Yeah. So let's look at this from the point of view of the front fill for a second. How much would I have to delay this front fill to get it to show up behind here? So I need it to be behind this upstage talker. So the upstage talker is coming in 13.2 milliseconds, and the front fill is coming in at 1.07 milliseconds. So how much delay would I want to put on that front fill to make this work?
When was the upstage coming in again?
13.2.
So you want like 18?
Yeah, I would say at least 18.
Probably 19.
So let's go to my front fills now. So I'll go into this, I'll go to my loudspeakers, and I'll say modify that front fill center left. And look, there's a delay variable there that you never even noticed. And I can put in 18 milliseconds into that, and it delays the loudspeaker. And I'll do the same thing with my center one. Eventually, once I get a number I'm committed to, I'll go ahead and dial them in on all the other ones as well, just for fun. Okay, so there we go. Now let's see what happens if I update this. Hey, look, my front fill moved. So there's my front fill now, and it's coming in at 19 milliseconds, which is, that's 19 milliseconds after the first arrival, and the first arrival was my downstage talker. So that is within precedence. Now, we also need to look at the upstage talker. The upstage talker is 13.2, and then the front fill is 19. So that is a little over 5 milliseconds, right? So that's technically within precedence as well. So that works. Okay, so let's take a look at our middle row now.
What about the loudspeaker?
We'll worry about, we'll solve the front fill first. Make the front fill work everywhere, and then we can worry about the center cluster. So the first thing, there's my downstage talker. Next thing, there's my center cluster. I'll forget about that for the moment. So there's my upstage talker at 12.9 milliseconds, so 13 milliseconds basically. And then my front fill's coming in at 18.6, so that works, right? That 18.6 is still within precedence. The talker is 13 compared to 18.6.
That's like just within.
That's barely, right? I may end up wanting to push this but remember, if I push it anymore, that is going to make that 18 bigger, which is going to be compared to downstage. So I'm going to be careful not to push that into echo, but I've got some room. I could potentially even widen my acting area here if I wanted to. Okay, so if we go to back row, we have downstage talker arriving first, upstage talker arriving 12 milliseconds later, and the front fill arriving 18.8. So still, pretty consistent pattern. That's pretty typical for front fills because they're on the same plane as the actors. They tend to arrive at consistent intervals regardless of the seat. Okay, so now I just got to make this center cluster thing work. So right now here at the back row, center cluster is coming in at 6.5 milliseconds. And I need it to be within precedence of this front fill, which is at 18.8. So what do I need to add to that center cluster?
12 and then 5.
So we would say at least 17 milliseconds. Let's try that. So, no, we want this one. So let's add 17 milliseconds to our center cluster. And I'll do the other one too. 17. Let's see what we end up with now. There, it moved. Okay, so now my center cluster is coming in at 23.5. My front fill is 18.88. So 19. So that's tight. Let's see what happens before I fix it. Let's see what happens the other row. So the middle row, we've got front fill coming in at 18.6. Center cluster coming in at 27. That's good. That's actually right in the sweet spot. Okay. And front row is coming in. We've got front fill there at 19. Center cluster coming in at 32.8. That's fine as well. That's like 13 milliseconds, 13, 14 milliseconds. So that's okay too. So this works. Yes?
And you could probably give it another millisecond to get the back row better.
I could if I want. Yeah, I probably could. I got some room. What the heck? Let's make it 18. Okay. So now what I need to do is, ultimately, I've got this whole thing backwards. If I look at the back row in particular, my downstage talker is the loudest thing. My upstage talker is slightly quieter. Then my sound system's riding around down here. Much quieter. That's just like the opposite of what I want. I want my sound system to be louder than my actor, right?
Yeah.
So I need to turn down my actors. Because right now my actors are doing 120 dB SPL at 1 meter, which
So maybe like 70.
they're not doing. I guarantee you they're not doing. So let's go ahead and let's knock that down at least 20 dB and see what happens.
You found Soundman J on Facebook.
What? Oh, yes.
He's a sound engineer. He was a sound engineer.
Apparently it worked for JBL at some point. So here you go. Now this is looking better. So here's my back row, and I've got my talkers hovering in at -10, and my cluster is at unity at 0. So now there's my 10 dB, right? In reality, I could push this a little bit further if I wanted to, because I've got that front fill in place. So I could make them even more. I could knock that down some more. Let's see what it can do. So downstage talker, let's take that down to -30. That might be a little too much, but let's just see. Upstage talker, -30. There we go. So this is pushing it. This is probably as much as I'm going to ever be able to do. But my center cluster is now hovering about 20 dB louder than my talkers, which I can probably get away with because of my front fills. Right? Because my front fills are slightly below that, and that's going to help that gap. Okay. So there you go. I did it.
Is the level that would you want to calculate the level that your speaker is going to be coming in at your top talker to make sure that that 20 dB over isn't actually going to end up being 10 dB when it gets down there?
What do you mean?
Because you said you don't want to go over 10 dB louder.
Well, 10 dB per hop. So per arrival. So that's what I'm saying is if I look at my front fill, I'm pushing it here. My front fill is just slightly more than 10 dB louder than my talker. So it's like 12. So this would be about as hard as I could push the system, and it would start imaging to the system. But it's imaging to the front fill at this point.
Okay, and
right?
then the center cluster images to the front fill, which is already imaging to the okay,
Yeah.
that makes sense.
So what happens is if I get to this spot, what happens is I'm going to start imaging to the front fill. But the front fill is where the actor is. And so the effect will be still somewhat intact. So this is why I say this is about as good as I'd be able to get, which is good. That's 20 dB of gain, and I've got a precedence image, or pretty close to one. That's worth taking a paycheck for. You know, if I can make the show 20 dB louder and have it sound like it's all coming from the actor, that's good. You know, people would actually pay me to do that. Okay, so as you can see, LARA can help simplify this a little bit. It forces you to solve it from the point of view of the listener, right? Because it's the only thing you can measure. You still have to figure out what the data means, right? Ultimately, it just tells you when things arrive at those listening spots. Then you have to decide what to do about that. So I was saying, well, I add a little bit of delay here, I'll adjust this level. I didn't ever adjust the levels of the loudspeakers because I've already done that. Like I've already balanced the levels of the loudspeaker for even coverage. So I didn't want to mess with that anymore. I just needed to get the system to be the right level relative to the actor. So that's why I just said, I'll just turn down the actor and to get this thing in line. And then ultimately, you know, what I would do, I mean, this is just a prediction at this point, a prediction of what I think will happen in real life. So what I would do is I would take those delay values that I came up with, and ahead of time, you know, when we're loading the system, I'd go ahead and plug them in on the processors. And then during the system tuning, we'd make some measurements and see how close we were. Like, is it working? Is everything lining up the way that we thought it would in the prediction? It'd save you a lot of time that way if you can preload those delay values in. I don't know if any of you participated at all in the measurements that you guys did with Guys and Dolls for the delay, but it probably took a long time to make all those measurements and dial that in. So if you can do that, if you can preload some stuff, and then it's just a matter of verifying and making little tweaks, that's how you can pull that off in a 4-hour call. Because if you do the predictions ahead of time, and you're not having to do it all on the fly. Unless you're really fast. And if you're really fast with the analysis equipment, then fine. But you're not really fast yet. So I highly recommend you do this. Questions? Does anybody want to guess what I'm going to ask you to do this weekend? Exactly what I've just done. Take your LARA file that has your center cluster in it, not mine. Therefore, you might have it in a slightly different location and a slightly different configuration. Hopefully you do. You're going to add some front fills to it. You're going to add some people onto that stage. And figure out, do what I've just done, figure out what kind of delays you got to put on the loudspeakers to get things to arrive. Install some listeners on the seats. Figure out what delays and what levels to adjust things to get it to work in Precedence. Then compare that to the data you did over this last week on paper. Hopefully it's similar.
Or an improvement.
Yeah. If it's not similar, then you need to decide what's different, like which one's wrong, and go back. If you think it's your paper that's wrong, go back to your paper and figure out where you messed up. Because if you've done it right, you should get pretty close to the same answer from LARA and from your paperwork. Okay? And then on Monday we'll talk about it. Any questions? Okay, well look at that. You can get started on it. You got a half hour left.